Okay. So yeah, like we said, this part what you have to understand is you need to know the part that you can what integrate and which part you can differentiate. So following what you're from doing, if you check, it is having both the the trigonometric and the exponential part. Now, it's your own duty to identify which one you're going to differentiate and which one you're going to what to integrate. So we have integral of e to x, right? Then sin x dx. So here, say following the formula, which is integral of u dv equal to u v minus v du. Automatically, I can just put this one to be my what u, and then this one to be my v. So v we take the part that has been integrated. If you are to integrate this one, is what I'm going to put where there is a v. So first of all, you have to do what you say. Let what let u be equal to e to x, right? Then v is going to be equal to what? The integral of this one. What is the answer if you integrate this? Automatically, I'm going to get negative cos x, right? So I need to differentiate this part. How am I going to differentiate? The differentiation of this one, if you're having a variable or maybe a constant number in front of x, it's just a matter of you dropping this and it will be a coefficient somewhere there. Meaning that du dx is going to be equal to what? It's going to be equal to 2e to x, something like this. Clear? Then once you continue doing your things, you understand that replacing in the formula now, which is okay, but before you do that, you need to make something as your subject in this case, which is that you can make du the subject of the formula by saying du going to be equal to what? 2e to x dx, something like that. So that where there is this in this expression, I'll replace with what? With this, yeah, as a whole thing. Then I remember I'm integrating what? This one. So I have to write it somewhere here by saying integral of e to x sin x. This is going to be equal to, here what is my u? I said e power 2x to be my u. V, I got negative what? Negative cos x, I close, say minus integral of what is my v? Which is negative cos x. Then where there is du, I said you have to replace with what? With this one, which is 2e to x dx. So remember, we can't integrate things with a number in between. You can move this one and it will come outside the integral. You're going to have the integral of e to x sin x equal to, not negative, it has to be negative because of this sign, cos x plus 2 integral of cos x, sorry, e to x dx, right? Again, here you have to pick the part which you can integrate as well as differentiate, since we are having this one to be our part. But this is going to be multiplied by everything that we're going to do on that side. So this is going to be integral of sin x equal to negative e to x cos x plus 2, and I put the big bracket. So here remember, to integrate this, we are using the same formula which is there. Where there is u, I can let my u to be what? My u to be the same thing. So say e to x, then where there is v now, the integral of this one is what? If you are integrating this one, what answer are you getting? You're getting sin what? Sin x, right? say minus integral of okay. Then you have to put uh, v, the integral. Sorry, okay, but I think it can still fit because okay. So I remember the integral of this one is what sine x, but whenever you let this one to be u and you differentiate it, we are getting that one, so it is going to be 2e 2x dx, and close like this. So you're going to understand that this part, these two has to come outside, and you're going to have e to the power 2x. Okay, so we're going to have e to x sin x equal to negative e to x cos x, right? So it's going to be plus 2 open e to x sin x minus, this has to come outside, to be 2 integral of e to x sin x dx, like this. So now you can multiply throughout by what? By the 2 which is there. So it will be integral of e to x sin x, giving us negative e to x cos x, plus if you multiply this by what is inside, automatically we're going to get 2 e to x x minus 2, sorry, 4, 4 integral of e to x sin x in here dx, right? So if you check this and that are the same, meaning that this can come to the other side. Once you take it that side, what answer are you going to get? You're going to have 5. That's why you're going to have 5 because this is now going to be plus, so e to x sin x, this is going to be equal to negative e to x cos x plus 2 e to x sin x plus c. Therefore, here you divide throughout by 5 so that the integral of e to the power 2x sin x can give us 1 over 5. You say open bracket negative e to x cos x plus 2e to x sin x plus c. This qualifies to be our answer.